Last time, when you visited Nuage, I talked about how that morning I had met the CIO of a Fortune 150 company, and how that meeting had gone wonderfully, because what that CIO was telling me with regards to the requirements in terms of them building a private data center that needed to be as responsive, as agile, as programmable, as automated as AWS. It was like, and by the way, he wanted a policy-based framework for all his workloads, bare metal and virtualized. And it was perfect because that is exactly what we had built as part of Nuage Network's virtualized services platform. Well, today I'm happy to report that that particular customer, after extensive testing, has selected Nuage Networks for their entire enterprise-wide private cloud deployment. They did extensive testing for multiple use cases that they had. Physical to virtual migration for workloads without re-IPing, without changing the IP address, critically important. They did testing of virtual to virtual workloads in hybrid hypervisor environment. And then they did testing of federation, multi-DC federation. Why? Because it's critically important for their mobility, for their disaster recovery use cases. And they also did policy-based automation testing for control and security for their virtualized and bare metal workloads simultaneously. And we think it's a hugely important win. The reason it's important is really on two important dimensions. One, of course, it validates in a big way our approach that we took in terms of having an open and flexible architecture that works on any network infrastructure, on any hypervisor technology, and independent also of any cloud management system. But more importantly, the decision that they took was independent of their existing network infrastructure and independent of their existing deployed legacy hypervisor technology. And this is the important trend, as I'm sure you all are seeing in the market, where really and largely because of the disruption that SDN is causing, enterprises for the first time in 2 decades are now able to select best of breed for their network infrastructure, for their SDN automation, and for their hypervisor technology. It's an important trend to watch. We are seeing it unfold as we go. What else did we do in the last year? We have now over 60 trial deployments and 10 important customer wins across the 3 theaters, EMEA, North America, and APAC. And by the way, these are across all the 3 customer segments that we serve: enterprise, pure play cloud service providers and hosting companies, as well as telecom operators. So that's what we've done. That's the state of the state, if you will. And we are pretty excited. So what are we going to do today? Well, we are super excited to show you 4 really unique things. As Steve said, we've set the bar high for ourselves, and we want to really live up to it. So 4 unique things that you're going to see, starting with hardware VTAP integration. And we're not going to just show you OVSDB and OpenFlow interface and claim victory. We're going to show you actually what we mean by hardware VTAP integration, how the resource, the actual VTAP, is truly abstracted and available in a multi-tenanted way as a resource in a policy framework, fully automated. Second, we're going to show you performance and scale. And performance and scale, orders of magnitude improvement over what other vendors have claimed in the industry. And why is this important? Well, control plane scale is important because of IP mobility, because of disaster recovery. For cases where the entire pod may have gone down and comes back up, all the workloads need to be authenticated, authorized, given IP addresses, connected to the proper IP subnet. all the ACLs and all the rules applied automatically. For all that to come up, how long does it take? It's an important factor. Next, we're going to show you containers. Yes, containers. So rather than profess our love for containers and provide lip service, like some other vendors are doing, we decided we'll actually show you containers in action. Yes, we already support containers in addition to virtualized workloads, in addition to bare metal workloads, simultaneously, concurrently for any applications in a fully automated way. And that's what you're going to see. And finally, best for the last, you're going to see what we truly mean by getting the network completely out of the way of the application developers or anyone who wants to deploy an application in a fully automated way. What do we mean by that? How easy can we make for the deployment of applications? That's exactly what you're going to see today. So here's the agenda. Florin Belus, who runs all of product management for Nuage, he's going to do a quick recap, give you a quick understanding of Nuage, and then he's going to do the demo of the hardware VTEPs, followed by Dimitri Stiliadis, who's our CTO at Nuage, and he's going to take you through performance scale, containers, and application designer. All right, here we go.
So I'm Florin Belus, I'm in charge of product management, and I'm going to split the presentation with Dimitri, our chief architect. Because I heard a lot of people are new to the product, we decided to actually start with Nuage introduction. I'm planning to get out of the way and get you guys to the demo quite fast, but stop me if you don't understand certain components. I'm basically available to go to the whiteboard if need be. I just know that from a previous Tech Field Day experience, people are interested in the demos more than just basic pure technology, okay? So basically, who are we? I want to start with that. So we started ourselves probably about 2.5 years looking at the cloud networking space. We think of ourselves as a leader in the software-defined networking space. And in the last 12 months, we saw a lot of success in the enterprise cloud service provider segments. We have a number of deployments, and basically, how did we start? How did we achieve this success? We started from the beginning by mixing cloud expertise, cloud technology expertise with networking expertise. So from the networking side, we have a number of people who build for maybe like 12 to 20 years different type of networking protocols for the internet, for virtual private networking, and I think we did about 2 times policy-based systems at scale that are powering your cellular phones, actually, and deploy systems, right? Basically, we are an Alcatel-Lucent venture, but we have our own building, we have our own control of the strategy, and we really focus on building best-of-breed open ecosystem around our software-defined networking. So I want to start by placing ourselves in the big cloud automation picture, okay? So this is an IP network interconnecting multiple server racks in a data center. And what I'm showing here are compute units with associated storage. So this could be like virtual machines, there could be like containers, right? And our focus is to provide networking between compute units, whatever they are. So usually what you have a tenant requesting application deployment, right? So they need basically compute units, storage resources, and they want networking and security. When they make the request for networking and security, those requests come to our solution, to our Nuage virtualized services platform. And we take them, we convert them into our brain, into our database, into our policy engine. And then we are waiting for the other components to instantiate what they need in the data center. So usually you have a compute management system like OpenStack pushing down virtual machines, or you can have containers. So in step 2, as soon as the virtual machine is positioned somewhere into a server in the cloud, automatically in step 3, an event goes out to our virtualized services platform. We basically identify the compute resource, and we generate a policy which includes security rules, networking rules. We are implementing basically after that in the network layer 2, layer 3, and layer 4 policy rules in a distributed fashion. And this is kind of, in general, what the service looks like from a logical perspective. You could have application running on different virtual machines. There is layer 3, there is layer 2. We basically provide distributed firewalling for those compute units on an individual basis. Or we can insert into the service topology a centralized appliance, being a firewall in this example, but there could be also a load balancer for that matter. So this is the overall process, and that's where we fit. Okay? We're reacting basically to placement of compute units all over the place. And if one compute unit moves for disaster recovery or virtual machine motion, we remove the networking primitives from the old server, and we reinstantiate it in the new location. So this follows basically the mechanism we implemented for large volume deployment of policy-based systems. The cellular phones are reacting like this. When you walk through, the networking follows you. That's basically what we did right from the beginning, following what we implemented in the past. And let me describe what's inside our Nuage virtualized services platform. So this is basically built around 3 components, all of them virtualized. Okay? At the top, we have our brain, virtualized services directory. This is where we have the network policy engine. This is where the translation happens between different type of language, application language or compute language, OpenStack, CloudStack, VMware. This VSD component is translating everything into an internal format, representing the commands, what the top layer wants us to do for them. Okay? So this gives us flexibility, and we took out on that flexibility and implemented interfaces for the main cloud management system from release 1.0 about 18 months ago. So we supported CloudStack, OpenStack, and VMware right from the beginning. This is basically running on a cluster of virtual machines for redundancy and scale. And inside we have also an analytics engine. This analytics engine provides basically the stats, the visualization of what's happening from a networking perspective. So this is implementing using a Hadoop cluster.
Most of your deployments, are they using VMware or OpenStack or CloudStack?
I'm going to talk about that, but there are all 3 of them. Actually, we have deployments with VMware, with OpenStack. Most of them lately were OpenStack, but we have also CloudStack because there were a number of CloudStack deployments, very large CloudStack deployments. We have one which has, like, I think, over 300,000 VMs. And they were running into scaling issues with the VR and all their usual systems. And we fit it right in there to address scaling concerns and service velocity. So all of them, actually, we hit all of them. And I will have a slide that talks about the use case, a mix of use cases in there. But you wanted to ask something?
No, just the architecture for the VMware one in terms of virtual switching. Like, are you manipulating the kernel switch, or just sort of plugging into that with a virtual appliance and a ESX host?
Yeah, I'm going to go down. This is at the top layer, right? This is at the VMware, vCloud vCenter layer, the top part. I will show you where we plug in, how we plug in into that part, because that's, I think, what you are asking, right? Let me go down the chain. Okay, so basically underneath the brain, basically it's the core, the engine of our system. So this is basically what the other people are calling controller. So this is our virtualized services controller. It's also running on virtual machines in a redundant configuration. And at the core of this controller, it's our Alcatel-Lucent service router operating system. So this is an operating system we fully featured for probably about 12, 13 years. I work in IP division. The main task we had when we put that in our controller was to actually remove features. There were too many in there. So we really took out whatever we needed in this controller. And actually, this is running probably in over 300,000 routers in telco networks. So it's a really solid piece of networking we have in here.
300,000 routers?
Yeah. I know it sounds like basically we had core routers. Right now the same runs into P gateway, S gateway, into the access nodes for the mobile networks. We developed probably about 4 Broadcom-based systems. So it's actually very, very well deployed. And it's a big business, so that's what keeps our bill paid, right? So it's a large deployment, and we had rich routing feature set here, okay? Very solid piece of networking. And then basically in the data path, so this is in the control path. In the data path, we implemented a virtual router and switching agent, okay? This one actually does more than just routing and switching, does also layer 4 policies and firewall, distributed firewall rules. So this agent basically was built to accommodate different type of data path components. So different type of hypervisors, containers. It's basically what brings the data path communication to the controller to a common format. So in reality, this runs on top of Open vSwitch. We started right from the beginning with the idea that we need to reuse open source development. And I think it was a good choice because we took it into the user space. So all of this VRS runs as a user space extension of OVS. OVS is our ASIC, and that allows us to easily certify with different distributions and follow up on Red Hat or SUSE or Ubuntu or Canonical easily because we don't touch the kernel. They port the kernel, we port basically in the user space. The certification, it's very little compared with the whole kernel space. Okay? And OVS is becoming better and better, more stable. We are looking to really help OVS develop very nicely. And we also developed, because at the beginning nobody had a hardware gateway and we wanted to accommodate physical workloads, bare metal servers. We developed a hardware gateway using off-the-shelf chipset. So we have a 1 terabit hardware gateway to adapt the physical world. And basically, this is where we also integrated with ESXi, KVM, and Zen. So this VRS agent, it's talking ESXi API or ZAPI for the Zen, or libvirt for KVM, and understands what's happening in there. When I talk about the VM popping up in here, the VRS agent listens to the hypervisor API, gets the full profile of the virtual machine, and tells the controller, I got this virtual machine. And the controller goes to the policy server and downloads the policy, implements the policy in the network. Okay? All the FIBs that I was talking about, layer 2, layer 3, layer 4, distributed firewall rules.
So for OVS, you're using their kernel, but you're not using their user space agent, right?
That's exactly, yeah. We're replacing their user space. We extended it because they are catching up, but that part was required.
Last year you were saying you did use OVSDB and OpenFlow. Is that still the case, or do you use something else?
We still use OVSDB and OpenFlow, and you will see some of the stuff. And we use, on the VMware case where you asked, we are actually implementing as a virtual machine with some hooks though. Because ESXi has a limitation of 1 million packets per second on the vSwitch, no matter what you do. So in order to get good TCP performance, you need to play some tricks with LRO to get it done. So we have done some work around there to get it, to give good TCP performance. So.
Okay, so moreover, so if you look at this controller, right, this applies to one domain, and that's what people call controller domain. The competition has a controller, and they expand this domain. They have to push scaling the controller brain, right? In our case, we do support similar scaling for one domain. Moreover, if you want to scale to implement SDN in other data center location around the world, you can simply add another controller. The controller, right from the beginning, were part of a controller federation. So the services can expand automatically without a VLAN provisioning step to other data center domains. And this is in sync with what we see customer want, actually. So basically, let me just show you how the networking is instantiated between domains, okay? So for one domain, you saw how the application request comes down and we interconnect VMs in one domain. Now, let's say this is Brooklyn Data Center's availability zone 1. Now, they want to expand to zone 2 in Manhattan data center. So they put a bunch of servers in there. They load our VRS agent, and basically they have to add another virtualized services controller in here. So basically, VMs in redundant mode implementing this function. they start talking to each other automatically. The service gets automatically extended here. There is no gateway required, no type of propagation of routes through some manager of manager. Everything is done automatically. And if you want to offer the services across wide area network, because our controller came from inside the router, talks basically router language, we basically naturally appear to routers, existing routers, as just another router. He doesn't know he's talking to two controllers. He's thinking he's talking to routers, okay? So I want to make sure I get to the demo. So basically, in a nutshell, this is what we achieve, the highlights of what we did from a technological perspective in 18 months. So right from the beginning, we started actually April 2013, policy-driven SDN. You hear people right now, 12 months after that, talking about policy-driven SDN. Big companies, this is the trend right now. We did it from the beginning. And from the beginning, we started with multi-domain controller federation, what I was talking about, and distributed layer 2, layer 3, layer 4 policies, right? No service node, no VR, no centralized traffic tromboning. From the beginning, distributed, everything distributed. And as I said, wide area network interoperability. We added in October 2013 service chaining to allow existing services, appliances to plug into our service. And we open it up for any appliance vendors. Okay? From the beginning, we were open to multiple cloud management systems and multiple hypervisors. And basically, we have consistent features between hypervisors and management systems. We don't have one controller for VMware and another controller for open source. This works in between VMware and open source. Okay? Full feature set. And basically, we are going to talk today about two new exciting technology additions that we did. So Application Designer is what Sunil was talking about, meeting basically what we saw happening in a number of deployments where people actually are trying to integrate into an application onboarding system. We came halfway and helped them probably shave off 4-6 months of development from their integration cycle with this. And then SDN for containers, this is not just us playing in the lab with this. We actually have a customer who pushed us to implement SDN for containers. And they deploy basically in their location, and they are experiencing the capabilities of our SDN solution with containers. So I wanted to talk about two customer use cases which are, I think, very exciting for me. I think this one in particular proves the capability we have to actually segment the cloud, the data center infrastructure. So this is a very large cloud provider. When we started, they announced basically 300,000 servers being deployed in Canada because it's very cold in there and was a good place to deploy. This is OVH. And we've always dreamed about getting into OVH and contacting the guys and working with them. And they are a fantastic team, very, very fast-moving team, technology-oriented team. Basically, they just announced a beta service offer, which I call Cloud as a Service. So basically, every one of their customers can go on their web page, push a button, and instantiate an OpenStack cloud with a Nuage SDN solution underneath. So every one of them basically gets what I am showing here. Cloud A, Cloud B, Cloud C, all of them, same structure, automatic deployment, distributed virtual routing and switching layer 4 services available to play with in there. If you have enough money, they're actually not that expensive. You can actually go and play in there. See our VSD monitoring service design capabilities. And we basically provide this segmentation across a shared networking infrastructure. So the servers are dedicated to the customers. We basically separate customer environment with our Nuage SDN solution.
But so that's a public-facing virtual private cloud solution that's running on.
Yes. This is a wholesaler in the sense that multiple cloud providers could come and buy and focus on their business rather than building an OpenStack cloud. I thought, we were thinking about actually doing this just for demo purpose, so they actually saved us the trouble. And we actually got a cloud just for lab as a service demo purpose from them. Any questions about it?
Every customer of theirs is going to have an independent Nuage, installed in it because it's OpenStack as a service.
Yeah.
Their own private cloud.
Yeah. Then I think what what I'm seeing, this is basically a repeatable use case that we're seeing again and again. So basically, a number of customers, they want an open ecosystem based on best breed. They actually have ESXi running into a number of servers, ESXi virtualization, they love it. They want to scale it, go beyond multiple clusters, establish networking, but they want to add also KVM as an open hypervisor, and they want to integrate their bare metal servers. They have lots of bare metal servers. So we are basically deployed as the SDN solution for this enterprise private cloud deployment. Usually they are multi-domain in different geographical locations. We have between 6 and 12 locations between different customers. But this is a trend we are seeing actually happening. These are not lab deployments, these are deployments. This is what Sunil was counting. So we have sold a number of lab deployments, but we're not counting those. I'm talking about basically real plans to put on top of it application consumption layer and all of that.